So he's going to videotape himself, so
Just me.
don't rattle all kinds of stuff while he's talking, because otherwise you're going to be listened to in his IU class.
Cool. All right. So, yeah, I'm Mr. Browdy. I think I've talked to most of you guys at this point, at least a little bit here or there. Unfortunately, this is my last day. I've got finals and whatnot coming up for IU, but I'm a pre-service teacher at IU, getting my master's degree in secondary education. Did biology before that, so I've been around IU for a while, been around Bloomington for a little while. So that's me. So today we're going to do kind of a plate boundaries activity to get just kind of in the swing of things with geology. So to start, we're going to do a little bit of review of just kind of earth structure and plate boundaries and whatnot. So first off, just the structure of Earth. We're going to go through it relatively simply. So in the very center, the Earth has a core. We have both the solid inner core and the liquid outer core. And then we have the mantle, which is going to be relatively important in what we're talking about today. And then the asthenosphere, the lithosphere, and the crust. So pretty much the outer layers. And that's what we're going to be mostly focused on today. And you don't need to be super worried about all the asthenosphere and lithosphere and terminology like that right now. Just kind of a quick review for you. But yeah, so today we're going to be focused mostly on the crust and the mantle. And so within the mantle, it's kind of molten rock, and so you get these convection currents as like the liquid rock is kind of circling around. And so these convection currents move the plates on the surface of the Earth. So you can get a few different kinds of interactions. You can get plates spreading, you can get plates coming together, sliding across one another. So you get a few different kinds of interactions that we're going to get to in a second. So if you check out, let's get this guy, there we go. So right here, the convection currents, as they're moving like this, they're causing the plates above them to spread. So this is over the ocean. And then here, when you get oceanic plates and continental plates, as the two of those are coming together, you're going to get the oceanic plates, which are a little bit lighter, going underneath. And so this is called subduction, and that happens when one plate goes underneath the other. And this is going to be pretty important here coming up. So just the types of plate contact. There's three main ones, and I'm sure you guys have seen this before. There's divergent, convergent, and transform plate interactions. So for divergent plates, as kind of the name suggests, they're diverging, so they're moving away from one another. So that's what we saw with the convection currents, like right in this last slide here. So right there would be a divergent plate boundary, where they're moving apart from one another, and as that happens, you get new rock coming up, or I guess new surface of the Earth coming up. So you see this a lot in the oceans. And then at convergent boundaries, so on coming together, you have plates colliding. And so, like I mentioned earlier, subduction, so you see this a lot when oceanic plates meet continental plates. But you can also see this when two oceanic plates come together or when two continental plates come together. So it's not limited to one or the other. And then there's transform faults, or transform fault boundaries. And so these are when two just kind of slide along one another like this. So three pretty simple interactions, but definitely have a variety of effects. So for divergent plate boundaries, you see these a lot, like I said, beneath the oceans, mostly in just like the ocean floor, and it's as plates moving apart. So this is like seafloor spreading, if you've ever heard that. This is what happens at divergent plate boundaries. And like I was saying earlier here, you get new rock coming up right here as those plates do spread apart. So then for convergent boundaries, you've got three types between the oceanic and continental plates. So when two oceanic plates come together, you're going to get one, you'll always get one going underneath the other. So that's subduction, and when that happens in oceanic plates, you're going to get volcanoes, or hotspots. So like with Hawaii, for example, that's kind of an island hotspot, and as the two plates are coming together, you're getting the islands forming. Then when you have oceanic and continental plates coming together, you have the thinner and lighter oceanic plate is going to be the one that goes under. And so when this happens, you also get volcanoes, but you don't get them as like ocean hotspots, you just get them as like continental volcanoes. And so that can also lead to mountains as well. And then you see this even more so when you have two continental plates coming together. And that's when you get like big high mountain ranges and things like that. So as the one plate will go under the other plate will kind of smash up and kind of like smush together mountain ranges. And then transform boundaries are pretty self-explanatory. They're just kind of the two rubbing together. And as this happens, you get a lot of earthquakes. And so this is what's called the Ring of Fire. And so this is a little counterintuitive map at first. North America's over here. I know we're used to seeing it over here. But so in this area between Eastern Asia and the Western United States, or really North America, you get a whole bunch of earthquakes right along in here. And so those, it's where a lot of the transform boundaries are. And so as those happen, you get just a really high incidence of earthquakes. And so what we're doing today is kind of a plate boundaries activity. So you're all going to get, this map. So you're all going to get a handout that has this on the back. And it's got kind of the major plate outlines drawn out. And so our goal is we're going to break up into different groups. And so we're each going to get a set of maps. And so there's 4 different maps, and they all have kind of a variety of different information on them. And the goal is, first we're going to talk together in our groups and figure out, okay, what the heck do these maps mean? What are they telling us? How can we check? What do we know from the scale? And things like that. So what are these maps telling us? And then we're going to get together into groups with 4 people, all who have different maps. We're going to kind of work together to figure out, for these boundaries, which of them are divergent, which of them are convergent, transform, or in some cases, which are just too complicated to tell. And so the 4 maps that we're going to have one, geography. It's a pretty self-explanatory map. It's kind of showing you elevation here. We're going to have geochronology, which is referring to like the age of the Earth. So different colors are here corresponding to how long the rock has been there. We're going to have a seismology map, which is pretty much just showing you earthquakes. We're going to have a volcanology map, which is showing you volcanoes. And so I'm not going to go into really much of the specifics of the maps. That's going to be on you guys to kind of figure out once we get together in groups. And so this is going to be kind of what we're going for here. I'm not going to put it up for too long. So we're going to have different colors outlined for different boundaries. So relatively simple. We're going to go ahead and count off really quick. We've got some colored pencils in the back, but we're going to break up into groups of numbers 1, 2, 3, and 4. Pretty simple. So let's start here. We'll start here and just kind of go through the rows. So counting to 4.
2,
3, 4, 1, 2,
3,
4,
1, 2, 3.
4, 1, 2, 3.
All right. So let's go ahead and split up. Let's do 1's up here, 2's back there, 3's back there, and 4's up.
He's bringing the maps. I've got papers.
You guys can distribute these amongst yourselves however you like.
Oh, if anybody wants something.
You all know where your groups are?
Thank you.
Celine, did you get one of these papers?
Oh, no, sorry. Thank you.
Wait, this isn't your group.
No.
Okay, it's like, why are there 5?
Okay.
Who is the group of 3? Is that 4?
Oh, that's
you guys?
4.
4's? Okay, I think one person is probably going to be in charge of 2 of the maps. So go ahead and just take a few minutes and kind of look at them together, and then we're going to actually split up into groups of similar maps. So we can all kind of figure out what each individual map is saying. So for these, just take a second, pick whoever has whichever map, but each person should be in charge of this one specific map. And then in a few minutes, so you guys have a second to like kind of look at them together, we're going to split up into all the volcanology maps, all the whichever, so you guys can like actually talk about them and figure out what you think they
Work together to figure out which ones to do. And then we'll come back to the group, and we have to combine all the information to get, figure out what it is. So read through this page first.